Well, first we learned how to use tangent, sine, and cosine to find unknown sides. Then we learned how to use the inverse sine, inverse cosine, and inverse tangent to find unknown angles. So putting all that together, now we should be able to find any unknown angle and unknown side in a right triangle if we're given enough information. Finding all of the unknown angles and sides is called solving the right triangle. So from now on, if I say solve the triangle, I mean find every unknown angle and every unknown side. So in this case, there are two sides I need to find and one angle. Well, let's go ahead and find angle P. Since I'm given one angle already, to find angle P, I can just do 90 minus 37. Okay, so the measure of angle P is just going to be 53 degrees. Okay, let's see, what shall we do next? Say if I want to find PQ, right? This is PQ over here. From the perspective of the 37, I'm going to stick with that. PQ is opposite, and the 22, of course, is the hypotenuse. So, if I'm talking opposite and hypotenuse, I'm talking about the sine function. So, I could do like this. Sine 37 will equal opposite over hypotenuse. So, that'll be PQ over 22. Of course, if I want to solve this, I'll just multiply both sides by 22. These 22s will cancel each other out. So that just gives me 22 sine 37 is equal to PQ. And that will just go nicely into the calculator. I should put boxes around my answers. So there's one of them. 22 sine 37. So 22 sine 37. It's 13.2. Where do they say round to? Nearest tenth. Yeah, so 13.2. All right, now that just leaves QR. Well, QR is adjacent. So from the perspective of the 37, I've got adjacent and I've got hypotenuse. So obviously that is the cosine function. So cosine 37 is equal to adjacent over hypotenuse. So QR over 22. All right, after that, it's pretty much the same as the last problem. Let's multiply both sides by 22, and that will give us our QR. All right, these will cancel out. So that gives us QR is equal to 22 cosine 37. In the calculator it goes 22 cosine 37. 17.6. All right, that's how you do number 4. Now, number 5. Let's see. There are 3 things we need to find. Angle P, angle N, and side PN. So there are 3 things we need to find. I'm going to go ahead and find angle P first. Okay, so focusing on angle P, what I have here is I've got 18 is opposite, and 11 is adjacent. All right, opposite, adjacent, that is the tangent function. So tangent of angle P is equal to 18 over 11, opposite over adjacent. Okay, we're supposed to find angle P. What is the special thing we use to find unknown angles? We use inverse trig functions to find angles. So we will do inverse tangent of 18 over 11, and that will find angle P. So I can just put this in my calculator. Inverse tangent of 18 over 11. Okay, so I'll do second tangent, and then 18 over 11. So that is 58.6 degrees. All right, so that's one down, two to go. All right, as soon as we have one angle, it should be really easy to find the other angle. So to find angle N, I would just do 90 minus 58.6, and that should give me angle N. So let's go ahead and get that down. So that's 31.4 degrees. Okay, so that just leaves Pn to find. Okay, so we're looking for Pn. The thing is, you've known how to find Pn in a situation like this since middle school. This is nothing new. Now, because we just found these angles, I could do, sine or cosine to find Pn. But I'm going to recommend not using sine or cosine, because it's always dangerous to use something that you just found to find something else. Because what if you got this wrong? Then it's going to cost you 2 questions instead of just 1. If this were a test, if you got this wrong and then you use it to find Pn, it's going to wind up costing you 10 points instead of just 5. So it is better to not use either one of these to find Pn. So how would I do it? Pythagorean Theorem. I've got 2 sides given. Find the third side. A squared plus b squared equals c squared. So that's what we're going to do. Okay, so Pn squared, that's my c squared, should equal 11 squared plus 18 squared. And I find it to be quickest, since I have my TI-30 XS multi-view, just to take the square root of both sides right now. So this will give me Pn equals, I'll just put that in my calculator, square root of 11 squared plus 18 squared. So here we go, square root of 11 squared plus 18 squared. So that's radical 445. I'll go ahead and write that down. All right, apparently that doesn't simplify anymore. But the directions did say let's give it the nearest tenth. So we can go ahead and decimalize that by hitting the toggle button. So 21.1 is the length of Pn. All right, let's move on. Number 6. Okay, again, as soon as I see that I have 2 sides given, I know I will find the third side using the Pythagorean theorem. So UT will be another Pythagorean theorem waiting to happen. But I'll save that for later. Let's find one of these angles first. Say if I look at angle U. From the perspective of angle U, 7 is opposite opposite, and 23 is the hypotenuse. Okay, so don't call it adjacent. Be careful. The hypotenuse is the hypotenuse. UT would be the adjacent leg. All right, the hypotenuse is not called adjacent. So I've got the opposite leg and I've got the hypotenuse. Well, that's the sine function. Hopefully you know that. So I will do the sine of u is equal to opposite over hypotenuse, 7 over 23. The angle is unknown. So how do I find unknown angle? Well, that's what inverse trig functions are for. You must show this work, by the way. You don't just skip to the answer. So this will be 7 over 23. This goes in the calculator. All right, 17.7 degrees. Okay, so that is angle U. If I want to find angle S, again, now I could do this all over again with, using a trig function, cosine. But if I'm feeling pretty confident about angle U, then I will do 90 minus 17.7. There is a risk, because if I got this one wrong, then it is going to cost me double. And I know I said on the last problem, to try to avoid doing that. So it's a judgment call. It is a risk using the value that I just used, but I am going to go ahead and do 90 minus 17.7. So that gives me that angle S is 72.3 degrees. Okay, if you wanted to be really safe, you would go ahead and do the cosine function and make sure that that's the right answer. Anyways, we have 2 out of 3 of the things. Now we need to find UT. Again, the best thing to do to find UT is to do the Pythagorean Theorem. A squared plus b squared equals c squared. Okay, so here's UT over here. So I will do UT squared. That's my, actually I almost messed up. 23 is the hypotenuse. So that's my c squared. UT is like my a. So I'm going to do a squared plus b squared equals 23 squared. Okay, so UT squared plus 7 squared will equal 23 squared. Notice when you do the Pythagorean theorem, the hypotenuse always goes by itself. Okay? So maybe I will turn these into actual numbers. So this will be UT squared plus 49 equals 529. Let's subtract 49 from both sides. That's 480. And take the square root of both sides. That's 4 radical 30. Okay, so UT is equal to 4 radical 30, which is approximately equal to 21.9. All right, so we found everything that was missing. Let's keep going. Number 7. Okay, what shall we find first? We need to find angle V. Might as well get that out of the way. Finding angle V is just going to be a matter of doing 90 minus 51. Okay, so that's just going to be 39 degrees. Okay. Let's go ahead and find MD next. Okay, so let's see. So here is MD. From the perspective of MD, no, not the perspective of MD, from the perspective of the 51 degrees, MD is adjacent and 14 is opposite. Okay, so what we have here is opposite and adjacent. That is the tangent function. So we will do tangent of 51 is equal to opposite over adjacent. So that's 14 over MD. Anytime the variable is in the denominator, that is a good time to do our shortcut where we can exchange these. The tangent 51, the whole thing will become the denominator. So if I do that, this will become MD equals 14 over tangent 51. And I can just put that in my calculator. So that is 11.3. All right, so that's 2 down, 1 to go. So we found MD. Now we need to find VD. Okay. So here's VD right here. So again, from the perspective of the 51, 14 is opposite. VD is the hypotenuse. Opposite hypotenuse, that is the sine function. Okay, so sine 51 is equal to opposite over hypotenuse. So 14 over VD. Again, the unknown is in the denominator, so we can use the shortcut. All right, so this will become VD is equal to 14 over sine 51. Into the calculator it goes. $18.0. All right, and that was the last thing that we needed to find on that problem. All right, let's keep going. Time for number 8. Let's get the easy one out of the way. Angle T should just be 90 minus 24. 90 minus 24. So that's going to be 66. Okay, so angle T equals 66 degrees. Put a box on that. Okay, what's next? Let's find TR. So here is TR. From the perspective of the 24, TR is opposite, and the 33 is adjacent. So this is opposite and adjacent. Opposite and adjacent, that's the tangent function. So tangent of 24 should equal opposite over adjacent, TR over 33. Well, the 33 is in the denominator, so the best thing to do is to multiply both sides by that denominator. That way the 33's will cancel out. And I will have TR is equal to 33 tangent 24. Just put that in your calculator and you get 14.7. Alright, that's 2 down, 1 to go. So now we still need to find side TA, the hypotenuse. So here is TA being the hypotenuse. So from the perspective of the 24, we've got the adjacent leg, and we're looking for the hypotenuse. So this is adjacent, and this is the hypotenuse. Adjacent and hypotenuse, well, that's the cosine function. So we do cosine of 24 is equal to adjacent over hypotenuse, 33 over TA. What do we do when the variable is in the denominator like this? You guessed it, we're going to do the shortcut and reverse these two. So that's going to give us TA is equal to 33 over cosine 24. Alright, and that goes right into the calculator. And that is 36.1. We found all 3 missing pieces. Alright, this is kind of a long homework assignment. But we shall persevere. Let's go ahead and find, notice when we find UM in a little while, we will do the Pythagorean Theorem. Anytime you're given 2 sides, you will find the third side using the Pythagorean Theorem. But I will do that later. Right now I'm going to find one of these angles. It doesn't really matter which one you pick. I'm going to go ahead and go with, I'll do angle U. Okay? From the perspective of angle U, I have opposite, and then I have the hypotenuse. Okay, opposite and hypotenuse, that's the sine function. So I will start off by doing sine U is equal to 19 over 28, opposite over hypotenuse. Alright, but if I want the angle, I do the inverse sine. So the inverse sine of 19 over 28, that should give me angle U. Just put that in your calculator. That's 42.7 degrees. Alright, well that's 1 down, 2 to go. Alright, I'm going to go ahead and take the easy way out and I'm going to find this angle by doing 90 minus 42.7. That gives me that angle E is 47.3 degrees. Okay, that's 2 down, 1 to go. All we need is the side UM. And like we said from the beginning, this is a job for the Pythagorean Theorem. Alright, because here's UM, It is one of the legs, so a squared plus b squared equals c squared. So I will do squared plus 19 squared equals 28 squared. Okay, I'm just going to do this. So, if I square everything, I get this. If I subtract 361, I get that. If I take the square root of both sides, I get this. All right, let's move on. All right, number 10. Let's see. So we've got, what do we want to find first? Let's go ahead and find AB. You know what? No, let's get angle C out of the way first. If I want to find angle C, I'm just going to do 90 minus 26. I'll just put that way up high. So that's 64 degrees. All right, 1 down, 2 to go. Let's go ahead and find AB next. Okay, so here's AB right here. From the perspective of the 26, AB is the adjacent leg, and meanwhile 4.5 is the hypotenuse. So adjacent hypotenuse, that's cosine. So we're going to use the cosine function. So cosine 26 is equal to adjacent over hypotenuse. So AB over 4.5. To get AB by itself, we are going to multiply both sides by 4.5. That way these 4.5s are going to cancel out. So I am going to have 4.5 cosine 26 is equal to AB. Put that in your calculator. That is 4.0. Okay, so that is AB. Next, so that's 2 down, 1 more to go. We need to find BC. So here's BC right here. From the perspective of the 26, all right, BC is opposite, and of course 4.5 is the hypotenuse. So what we have here is opposite and hypotenuse. Well, that's the sine function. All right, so sine of 26 should equal opposite over hypotenuse, BC over 4.5. Our next move is to multiply both sides by 4.5. That way these 4.5s will cancel each other out. And that leaves me with 4.5 sine 26 is equal to BC. And that's basically the answer. We just need to put it in the calculator. That would round up to 2.0. All right, that's the end of that problem. Let's just a few more left. So number 11. Let's do the easy thing first once again. If this is 20, then of course this is going to be 70, because I'm just going to do 90 minus 20. So angle V is equal to 70 degrees. Okay, easy enough. Now let's find one of our sides. I'm going to go for WV first. Okay, so here's WV right here. From the perspective of the 20, all right, WV is the opposite leg, while 12 is the hypotenuse. So what we're dealing with is opposite and hypotenuse. That is the sine function. So we will be thinking sine of 20 is equal to opposite, or WV, over the hypotenuse, 12. Then it's time to multiply both sides by 12. All right, those will cancel each other out. So that's going to give me 12 sine 20 is equal to WV. That's basically the answer. We just need to put it in the calculator. That is 4.1. All right, that's 2 down, 1 to go. Well, now we just need WX, which is right here. Okay, now from the perspective of the 20, okay, from the perspective of the 20 degrees, WX is adjacent, and 12 is still the hypotenuse. So adjacent and hypotenuse, that's the cosine function. Okay, so we will say cosine of 20 is equal to adjacent over hypotenuse, WX over 12. Time to multiply by 12 on both sides. So multiply by 12, multiply by 12. So that is going to give us 12 cosine 20 is equal to WX. That's basically the answer. It just needs to go in the calculator. So that's 11.3. All right, that is it for number 11. Let's do number 12. We're almost done. Okay, once again, they gave us one of the angles, so we should be able to take care of this very quickly by doing 90 minus 31.6. So that will give us angle J right away. So angle J equals 58.4 degrees. Okay, so that's out of the way. All right, now let's go back in and find one of these sides. I will start with LK. All right, so here is LK right here. Now, from the perspective of the 31.6, from the perspective of this angle right here, LK is the adjacent leg. And the 7 is the opposite leg. Opposite and adjacent. That's the tangent function. Okay, so we will do tangent of 31.6, and that should equal opposite over adjacent. So 7 over LK. Notice how the unknown is in the denominator. Well, that is when we reverse these two. So that's going to give us LK is equal to 7 over tangent of 31.6. And this is basically the answer, but we can put this in the calculator. This is 11.4. All right, that's 2 down, 1 to go. Now we just need side JL. All right, JL is right here. From the perspective of the angle here, the 31.6, 7 is still opposite, but JL is the hypotenuse. Opposite over hypotenuse. That, my friends, is the sine function. So we will go sine 31.6 is equal to opposite over hypotenuse. So that's 7 over JL. Once again, the unknown is in the denominator. So that is when we want to use the shortcut and reverse these. So this will become JL equals 7 over sine 31.6. And this is basically the answer. We just need to put it in the calculator. And I am getting 13.4. All right, that is the end of problem number 12. All right, one more problem. Problem number 23. Okay, focus your eyes on this triangle right here. The triangle that would be formed if we extended this diagonal line all the way down to the ground. This is one of those Z angles that we used to talk about. Bam, bam, bam. So remember, this is going to be 55 degrees. Let's blow that up. All right, so this angle right here is 55 degrees because it is an alternate interior angle with this one. It's a Z angle like we used to talk about. And those Z angles are always going to be equal. Now, how does that help us? Well, let's focus even more carefully on this triangle right here. Okay, let me just copy that and pull it out so we can analyze it more. Now look, this is a right triangle, and I've got the 55 degrees right here. I just copied that straight down. Do I know how long this side of the triangle is right here? Well, I do. I mean, look where this came from. This is the height of this building, and it's 200. Okay, so I know that this side of this triangle is 200. If I could find the bottom side of this triangle, that would put me one step closer to finding how big x is. So let's go ahead and do that. I'm going to call this y. Now, based on everything we've done over and over again in this lesson so far today, I should be able to find this y with no problem. Let's see what I have. From the perspective of the 55, I have opposite and adjacent. This is the tangent function. So that means tangent of 55 is going to equal opposite over adjacent. That's 200 over y. When the variable is in the denominator, I do the swap. So that's going to be y is equal to 200 over tangent 55. Okay, so let's put that in the calculator. So that comes out to be 140.0. So that means this distance right here is 140. Okay, keep that in mind. So this distance is 140. Now, if I knew what the whole distance was, okay, from one side to the other, I could just subtract 140 and that would be my x. Well, I can do that if I focus my eyes on the big triangle. Let me just copy that out as well. And I'll put that over here. So look, here's the big triangle. So I should be able to solve this because, see this 55? That's also this angle right here. Just like last time I knew this was going to be 200, how tall is this side of this triangle? I feel like I should change colors. I'll go green. 320. This side should be 320. Am I right? Because that's the height of this building. So, if I want to find this bottom, and I will call it W. I'll just call it W. I should be able to find W, and W is going to be this whole length right here. Okay, so let's see. Well, it's going to be the same situation. 320 is opposite, and W is adjacent. So again, I'm doing the tangent function. So I'm doing tangent of 55 should equal opposite over adjacent. Again, the variable is in the denominator, so W will equal 320 over tangent 55. Put it in the calculator. I get 224.1. Okay, so that's W. Now that is the length of this whole bottom right here. So this is 224.1. So if the whole distance from one side to the other is 224.1, and I know that part of that distance is 140, if I want to find the leftover part, I will just subtract. So let me switch over to blue. Okay, and let me do this calculation down here. Okay, so basically this is what I had. I had this whole length and it was divided into two pieces. Part of that was x, this part over here was 140, and I knew that the whole distance was 224.1. So the relationship here is x should equal 224.1, the whole thing, minus 140. Okay, so just put that in the calculator. And that is 84.1.